Hello students of grade 9, grade 11. We're going to do some extra questions of exercise 2.2. Question number 1, let A, B, 1, 2, 3, 4, 5, 6 define a relation R, A to A, by R equal to XY, Y equal to X plus 1. So you have to get the relation, okay? And the relation is from A to A, that means we can use only these elements. We cannot use other than 1, 2, 3, 4, 5, 6. And the condition is y is equal to x plus 1. If is given here y equal to x plus 1. If x is 1, I can use this number only. Y is 2. If x is 2, y is 3. If x is 3 plus 1 means y is 4. If x is 4, y is 5. If x is 5, y is 6. If x is 6, y is 7. Since 7 doesn't belong here, we cannot use this. So I can use this only. If x is 1, y is 2. Y is 1 more than x. If x is 2, y is 3. X is 3, y is 4. X is 4, y is 5. X is 5, y is 6. I can use only this element. So what will be domain? The first element is domain 1, 2, 3, 4, 5. The second element is range 2, 3, 4, 5, 6. Clear? Let's go to next question. I've already done the cross product. A is given, B is given. Our relation is xy such that xy belong to A cross B and y is x plus 1. Same. Okay. So I have first question is find A cross B. So I got A cross B 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. Now the relation. Second, you are going to find the relation. Relation is y is 1 more than x. That means this can be the second is 1 more than the first number. Y is x plus 1. So when x is 1, y is 2. I can write 2, 3. I can write second number must be 1 more, so 3, 4. Second number is 1 more than the first one. So this is a relation. Domain will be, find the domain and range. So domain will be the first element, that is 1, 2, 3, and the range will be the second element 2, 3, 4. Now we have to represent, the fourth question is represented by arrow diagram. So 1 is related to 2, 2 is related to 3, 3 is related to 4. This is set B. Set A has 1, 2, 3, set B has 1, 2, 3, 4. So I wrote set A has 1, 2, 3, set B is 1, 2, 3, 4. 1 is related to 2, 2 is related to 3, 3 is related to 4. Okay. Question number 3. A is an set which contains 1 till 25. 1, 2, 3, 4, 5, 6, 7, 8 till 25. Okay. And the relation R is 1/4 of in A. So first element is 1/4 of the second. So 4 is 1/4 of 4 is 1 like that. 2 will be 8. If I divide these two, I'll get 2 by 8 means I'll get 1/4. If I use 3, 3 will be 12. If I divide these two, I'll get 1/4. 3 by 12, I get 1/4. If I use 4, it will be 16. If I use 5, it will be 20. If I use 6, it will be 24. If I use 7, it will be 28, but the set is still 25, so I cannot use 7. If I use 7, it must be 28, but 28 is missing here, so I can use still 24. Write R as a subset, also find the domain and range. So domain and range is easy. First element, that is 1, 2, 3, 4, 5, 6. Range of R is second element, 4, 8, 12, 16, 20, 24. Let's do question number 4. In the set of natural number, let R be the relation defined as A related to B. IFF means if and only if, okay? In mathematical language, IFF means if and only if A, B belong to N, natural number. And they have given A plus 2B equal to 11. So let us get the relation. Using this relation, okay? So I'll just write A equal to 11 minus 2B, or we'll just try to find out B. 2B equal to 11 minus A, so B is 11 minus A by 2. Natural numbers start from 1. If I put 1, what I'll get? 11 minus 1 by 2, that is 10 by 2, 5. I get 5. If I put 2, 11 minus 2 is 9. We cannot cancel by 2. So I'll put 3. 11 minus 3 by 2. So 11 minus 3 is 8 by 2. I get 4. So when I put 3, I get 4. When I put 5, if I put 5, 11 minus 5 is 6. Divided by 2 will be 3. 5 is 3. If I put 7, 11 minus 7 is 4. And if we divide by 2, I'm showing here, see, B equal to 11 minus 7 by 2. That is 4 by 2. I get 2. 7 is 2. If I put 9, 11 minus 9 will be 2. And if you divide by 2, we get 1. So this is the relation, okay? Find the domain and the range. So domain will be the first element, that is 1, 3, 5, 7, 9, and range will be second element, that is 5, 4, 3, 2, 1. Let's go to question number 5. Here they say that R is a relation on Z. Z is in integers, okay? All the positive negative number and 0 together is integers. And the condition given here is A belong to Z and Y belong to Z. A square is equal to B square. So what will be the relation? First element will be A. How to find the second element? They said A square equal to B square. That means I can say B square equal to A square. If I remove square, I have to write plus minus root over A square. That is plus minus A. The second element will be plus minus A. Because the relation is AB, in place of B, we're putting plus minus A because B is plus minus A. And where A belong to integers. Clear? Now what will be the domain if you see domain A is integer. This is Z, okay, sorry. A is integer, that means domain will also be integers. If I put 1, I'll get plus minus 1. If I put 2, I'll get plus minus 2. So domain will be all the integers, okay. Even the range also will be nothing but integer. Plus minus any number is an integer only. Let's go to question number 6. A is given as 2, 3, 4 and B is given as 3, 6, 8. Find a relation R such that X divides Y. The first number must be able to divide the second number. So 2 can divide which number? 6. So 2, 6. 2 can divide 8. 2, 8. 3 can divide which number? 3 can divide 3. And 3 can divide 6. 4 can divide which number? 4 cannot divide 3. 4 cannot divide 6. 4 can divide 8. So last one is 4, 8. So this is your relation. Question number 7. Let R be a relation less than from A to B, okay. Write down the Cartesian product corresponding to R. So we're going to find R only. They're saying less than. So we'll see A and B. So we can say, I'll just say A is 1, 2, 3, 4, 5 and B is 1, 4, 5. So we have to see that 1 is less than which number here? So 1 is less than 4, 1 is less than 5. So 1 is less than 4 as per the relation, okay. 1 is less than 5. Now I'll check with 2. 2 is less than 4. 2 is less than 5. We'll check with 3. 3 is also less than 4 and 3 is also less than 5. 3, 4. 3, 5. Next we'll check it 4. 4 is less than 5. 5 is less than nothing here. So this is the relation. They are also asking you to find the inverse of the relation. So inverse we represent by -1. So we'll write all ulta BA, that means it will be 4, 1, 5, 1, 2, 4, 5, 2, 4, 3, 5, 3 and 5, 4. Inverse means we write BA, okay. First this one, second this one. 5, 1, 4, 2 like that. Let's go to question number 8. Determine the domain and the range of the following relation. And x is a natural number and x plus y is 10. So natural number means if I use 1, 1 plus 9 will be 10. So 1, 9 I can write. 2 plus 8 will be 10. So 2, 8 I can write. Sum of these two must be 10. 3, 7 I can write. 4, 6 I can write. X plus y is 10. 5, 5 I can write. Only natural number I am using, okay. There is no negative number or 0. 6, 4 I can write. 7, 3 I can write. 8, 2 I can write. 9, 1 I can write. 9 plus 1 is 10. So this is the relation. Clear? Find the domain and range. So domain will be, domain is the first numbers, first element. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So range is the second element. So 9, 8 like that. 9, 8, 5, 6, 9, 8, 7, 6, 5, 4, 3, 2, 1. You can write 1, 2, 3, 4, 5, 6, 7, 8, 9 also, no problem, okay. Domain and range. Meaning is same only. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, second one, xy. x belong to n and x is less than 5 and y equal to 3. First find the relation. Y must be always 3, whatever may be the value of x, but x value is from 1, 2, 3, 4, less than 5. So if x is 1, y is 3. If x is 2, y will be 3 because y is always 3. If x is 3, y is 3. If x is 4, y is 3. So domain will be 1, 2, 3, 4. And the range will be 3 only. Last question, extra question, question number 9. A relation R is defined on the set of integers as follow. xy belong to R implies x square plus y square must be 25. Simple, okay? If I use 0 square plus 5 square will be 25. And it goes with the negative number also. 0 square minus 5 square also will be 25. See, 0 square plus 5 square will be 25. If I put 1 in x, well, 1 we don't have a connection. If I put 2 square we don't have a connection. We have to get a number which can satisfy this. Okay, it's like Pythagoras theorem. We can use 3. 3 square plus 4 square is always 25. That is 9 plus 16 is 25. So 3 can be 4. I'm using 3, 4. Or it can be 3 can be negative 4 also. Or negative 3 can be 4 also. Or if both negative also, no problem. Okay. Minus 3, minus 4 also, no problem. If I square this also, we get a relation. Similarly, it will go as 4, 3. If you can do 4 square plus 3 square also is 25. So if it is both positive, no problem. First one negative, second one positive. If I square these two numbers also, it will be 25. Or it can be minus 4, minus 3 also. Or it can be 4 minus 3 also. So these are the relation. Okay. Now you have to write R inverse. So we have to write ulta. It will be 5, 0 minus 5, 0 4, 3 minus 4, 3 4 minus 3 minus 4 minus 3 3, 4 3 minus 4 minus 3 minus 4 minus 3, 4. So we got the R and R inverse also. Hence find the respective domains or domains of R. The first element, that is, I can write 0, 3 minus 3 4 minus 4. And domain of R inverse, I can write 5 minus 5. Oh, I forgot to write 5 also. Here we can write 5, 0 also, minus 5, 0 also. I forgot to write this. Okay. 5 and minus 5 also. Similarly, range also will be same. I can use 0, 3, minus 3, 4, minus 4, 5, minus 5. Both are same, okay? You can pause the video to write everything. Thank you.